It's very difficult to cover every aspect of a van build. I've sort of tried to give back to some of the community by doing my van build. It's a rare van, I think, to find on YouTube, really, with such a series. The sprinters, etc., are common, and for obvious reasons. From the beginning, I didn't think that I would do a van build series, really. There's a lot of respect for people that have, because there is a lot of work, a lot of time, a lot of dedication to doing a van build, and to add to that, producing videos and interesting content is quite another load to take on. So every aspect of my van I've not covered from the beginning, and that is because some of the aspects of what you do from the beginning. So this is about solar panels, which I've been asked to do, and I'm quite happy to do that. And there's a couple of things in here which I hope will help people if you're not totally electrically biased. So from the beginning, you know, one of the first things really that you would do is the first fixed wiring. Whether that goes on top of or underneath the insulation doesn't really matter, but it's a thing that you would put in very early. And during that sort of time, I didn't know I was doing this series. I've not covered everything. So you need 2 cables up to your roof and come out on a waterproof outlet. I've used 6mm tri-rated, and you run it in flexible 20mm conduit just to protect it from chafing, etc. So you run two cores basically from where your electrical installation is going up onto the roof, coming out underneath where your panels will be, however much you're putting on the roof. Most solar panels I think that you get for camper vans now are monocrystalline, and those are the ones that you should choose for the most output. I think the biggest advantage with those is that if they are partly shaded by a tree or something like that, the rest of the panel will still give you a decent output. 2 cores from your electrical installation up to the roof, 6mm, and that needs to go through an isolator. Now, if you've got multiple panels on your roof, you need to use the proper PV connectors to connect everything up. And it's difficult for me to show you them just now, but on my roof I've got 2 Y connectors. So that's 1 in, 2 out, and the other one is 2 in, 1 out. Your solar panels will come with usually a relatively short lead on with a PV connector on, and so you can use that. These are Renogy 200 watt panels, and they come with, I think it's 1 meter of cabling, which in my installation was plenty. So I'm going to do a rough drawing for you just to explain 2 differences. The choice of this is going to depend on what MPP controller you need. And just for those that are maybe watching this and don't understand this bit yet, you cannot just connect a solar panel to a battery. You will absolutely cook it in the summer within days. You need a controller, which is a bit of kit, which basically, it not only drops the voltage of the panel down to the charge voltage for the battery, it also controls the current and it monitors the battery. When the battery's full, it will stop the current from the solar panel going to the battery, so it monitors the charging of your battery. So each of these panels is essentially 12 volt, but we're going to use that as a very nominal figure because actually the voltage of my panels is 23 volts, but they are essentially called 12 volt panels because they charge 12 volt batteries. 12 volt batteries is a very loose term because lithium batteries will go up to 14 volts. We have a positive and a negative from each solar panel, and in this case we are going to connect them in parallel like that. In this case we are going to connect them in series, and there are 2 differences here but 1 outcome. So let's say that each of these panels are 100 watt panels. So we have 2 panels connected in parallel, so the voltage will be 23 volts. Because they're connected in parallel, we add the current together and that will be potentially 16 amps. Sorry for my crap writing. And essentially we've got 200 watts available to us. That 200 watts is going to be the same for both examples. This one over here, we have got 46 volts at 8 amps. So in the first example, we've connected them in parallel. So the voltage is going to be the same that each panel can output. So that's 23 volts. But obviously through the MPPT, that will be 12, 13 volts. But because we connected them in parallel, the current is added together. So each panel's got the potential of 8 amps. So in this example, we've got the potential of 16 amps. In this example, we've got the panels connected in series. So we add the voltage together, and the current is what each panel can produce at maximum. So that's 8 amps. So the current stays at 8 amps, but we add the voltage together because it's in series. So potentially the output of this one is 46 volts. Now the main reason for choosing these two different wiring patterns is you need to look at the spec of your MPPT unit, and it will tell you what the maximum input voltage is. That maximum input voltage is going to be the no load voltage. Once you put a load on, the battery is going to drag down the voltage of the solar panels. But with no load on, the input to the MPPT is going to be the output voltage of the solar panels. Okay, so have a look at your MPPT specification and it will tell you what the maximum input voltage is. And I think mine was less than 46 volts. And so I cannot wire my solar panels in series. So mine are wired in parallel. And I know that the voltage will never go over 23 volts because that's the maximum voltage on the panel. But I've got a potential of 16 amps, which the MPPT can handle because it can handle up to 25 amps. So basically that is how you choose if you are putting 2 or more panels on your roof. That is why you choose the differences in how you wire them. Obviously 6mm will easily cope with 16 amps, but I've used 16mm because again it was over about, I think, 5 meters. You've got to consider a little bit of voltage drop there. But looking at the reading on the voltmeter, I think it reads this morning it's about 22.1, and that's sort of early morning sun. And really that pretty much covers solar installation. As regards fixing them to the roof, I was going to be using cross beams on my unistrut, so I've mounted 2 lots of unistrut on spacers on the roof as like a kind of like a roof rack, roof bars. I was going to put crossbars on, which I had prepared. It was those, so my solar panels were going to be fixed to here. But the Renogy solar panels have got like a C-section aluminium extrusion on them. So I've bolted the bottom of that straight onto those roof bars. So I've probably saved myself 20 or 30 kilograms there. So solar panels are relatively simple, really. You've just got to follow a couple of basic rules. And that is check on your MPPT controller or whatever controller you're using. It will have a maximum input voltage. And if you're installing multiple panels, that will determine how you connect them up. So connecting in series, you add the voltage together. Connecting in parallel, you add the current together. And then you just bring your cables down in trunking in the van to an isolator through an overload. That just protects the cable into your MPPT. Things to bear in mind with solar panels is the quoted manufacturer's output is only going to be achieved under, you know, very ideal conditions. So that's going to be somewhere near the equator with the sun at its highest point and the panel completely clean. Under those conditions is only when you're going to expect anywhere near the maximum output. I've got 400 watts in total, so it's late April, but had some really good weather. But I think the most I've seen is about 220 watts out of 400. The sun is not quite as high yet as it will be, for example, in June, and that's when I can expect to see the highest output. Yeah, so that's pretty much it, really. And yeah, I wish I could have maybe covered this in more detail, showing the installation on the van, but there's not really a lot to see. Your cables, same as any other cables really, buried in the van in conduit. Those cables go to a PV connector if you're connecting up multiple panels, you need like a Y connector. Only use PV connectors. Don't use any other connectors because they are waterproof. I've sort of laboured over things a little bit to try and expand it, but there's not a lot else more to say about solar than that. Once you get it up and running and connect it, gotta say, it's really nice to see free energy coming in and charging your batteries or running your kit. Even if I'm getting only a little bit of solar, it's running my fridge for nothing because my fridge takes 60 watts. And so, you know, that's kind of like free energy. But if you've got any questions, post a question below and I'll certainly try and answer it. Thanks for watching.